consideration. So let's look at complement of a set. Complement of a set. So let A be a set. Let A be a set. We are considering a set now. Then the complement of A, denoted by A complement, while some authors write A prime to mean the complement of A. Now is the set of all elements, elements in the universal set, which are not in A, which are not in the set A. They are not members of it. A. They are all elements in a particular universal set, which A is a subset of that universal set. Then the elements are not in A, and we denote this by A complement. I prefer to use A complement like this. Is the set of all element X such that X is in the universal set and X is not in A. So this refers to all the elements in a universal set that are not in a subset of the universal set A. So this is the complement of A. Example 1. Let's start with example. Example 1. So let U be equals to 1, set containing 1, 2, 3, up to 10. And let A be equals to, say, 1, 2, 3, 4. Then what is A complement? What is A complement? Now, A complement, in this case, is equals to all the elements in the universal set that do not appear in A. A has 1, 2, 3, 4. Then 5, 6, 7, 8, 9, 10 are the complement of A. 5, 6, 7, 8, 9, and 10 are the complements of A. These are elements inside the universal set that do not appear in the set A. So, example 2. Let U equals to set of all X such that X is a student of a particular university. Student of, let's take ABU as an example. And A be denoted by set of all Y such that Y is a mathematics student. Is a mathematics student. But what is A complement? Now, A complement is equal to this. Is the set of all X, meaning all students, such that X is not equal to Y. So that is all students in the university that are not mathematics students. So another example is university students consist of male and female. So you have U, we have U is equals to a set containing the male and female. So these are male and female. These are elements of a university student. So the complement of male is what? Female. And the complement of female is equals to what? The male. Male students. So M complement is F, and F complement is M. Because the entire university, that's the universal set, consists of just two basic subsets. The subset containing male and the subset containing only female students. This discussion is going to be based on cardinality of a set. Cardinality of a set. So let A be a set. The cardinality of A, written as, we write it as, written as the size of A, or some authors will write N of A, now is simply the number of elements in A. That is the cardinality of A. Consider this set, example 2. Example 2. Let A be equals to 1, 2, 3, and 6. So the cardinality of A here is the number of elements in A. And the number of elements in A can be counted 1, 2, 3, 4. 4. We have 4 elements. So the size of A is 4. So another example, example 3. Example 3. Let A be equals to 1, 2, 3, and then up to 10. What is the cardinality of A? So the cardinality of A in this case is 10 because the number of elements in A is 10. Remember, we use these 3 dots to simplify notation that we don't have to. These 3 dots is indicating that there are other elements which are skipped, but they are still captured in the set, but we don't want to write them just to simplify time, to save time and space. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are represented by this dot, and the last member is 10. And so we have 10 elements in this set, so the cardinality of A is 10. Our next topic of discussion is the power set. The power set. Power set of a set. So let's B be a set. So consider B as a set, then the power set of B, written as, we write it as, written as P of B, is the set of all possible, is the set, or you can say collection, the set or collection of all possible possible subsets of the set B. We can take example. Example 3, example 4 here. We have let A be equals to 1, 2, and 3. So we have the power set of A. The power set of A is equal to, we open a bracket, a set bracket. Recall that every set is a subset of itself, and the empty set is a subset of every set. Under this, listing the possible subset of A, we have start from the empty set. Then this is a set containing no element. Then we move to the, for easy, for us to write the element easily without skipping any member, we start from the empty set, a set of cardinality 0, and then we start, next we move to a set of cardinality 1, a singleton set, and then set of cardinality 2, set of cardinality 3, and until we exhaust all the possible subsets of E. So we have set of cardinality 1, so we continue only 1. There's possibility of set containing only 2, and there's possibility of a subset containing only 3, and then we have exhausted the singleton subsets. Now we will go to the subset of cardinality 2, 1 and 2. So this is a set containing 1 and 2. Another subset can contain 1 and 3. Another subset can contain 2 and 3. And then 1 and 2 as a subset, 1 and 3, and then 2 and 3. So the last subset here can be a subset containing the whole A itself, 1, 2, 3. Or you simply write A in place of 1, 2, 3, because a set containing 1, 2, 3 is the whole A itself. So look at 1, 2, 3, 4, 5, 6, 7, 8 elements. Now let's look at example 5. The fifth example here, let B be equals to a set containing 1, 2, 3, 4 elements. Then the power set of B is equals to the set containing, no empty set is the first, and then set of singletons. So we have 1, a set containing 2, a set containing 3, a set containing 4, a set containing 1 and 2, the doubletons, a set containing 1 and 3. Next, a set containing 1 and 4. Next, a set containing 2 and 3. Next, a set containing 2 and 4. So 1 and 2, 1 and 3, 1 and 4, 2, 3, and then 2, 4, and then a set containing 3, 4. We are done with subset containing only 2 elements. Now to move to subset containing 3 elements. We have 1, 2, 3. We have 1, 3, 4. So we have another one containing 2, 3, 4. Then 1, 3, 4. 1, 2, 4. 1, 2, 3. 1, 2, 4. 1, 3, 4. So we have 2, that is 1, 2, 3, 4, because every element, every set is a subset of itself. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible subsets of B. So cardinality, let's look at cardinality of power sets. So consider a set, let A be a set of size of cardinality n, then the power set of A, the size of the power set of A is equals to 2 raised to the power of n. We have examples here. Since A is of cardinality 3 and A is of cardinality 3, then the size of the power set of A is 2 raised to the power 3. And that is 2 times 3, 2 times 2 times 2, and that is what? 2 times 2, 4 times 2, 8. And that is why you have 8 elements here. So if you list 7 elements instead of 8, then you have to go back and check. Definitely 1 element is missing and you have to find it. So in this case, if n is 4, so you see the number of elements here is 4, and that is 2 times 2 times 2 times 2, that is 2 times 2, 4 times 2, 8 times 2, 16. So the number of elements in the power set of B is 16. So in case you list 14, you have to check. You have to go back and check again until you find the missing element in the subset. I mean in the power set. Next, let's discuss about disjoint subset. Disjoint subsets. So let A and B be 2 sets. So A and B are said to be disjoint, are called disjoint. Disjoint, this is D, disjoint. If A intersection B is equals to empty. That is, A and B have no elements in common. So there is no element of A that is also an element of B, and there is no element of B that is also an element of A. Example, this is possibly example number 6. So let A, consider A to be equals to 1, 2, 3, 4, 5, and B be equals to 6, 7, 8, and 9. Clearly, it is clear. Clearly, A intersection B is equals to empty because they don't have anything in common. 1 is not here, 2 not here, 3 here, 4 not here, 5 not here. So A and B are disjoint. So we conclude A and B are disjoint. Disjoint subsets. So let M equals to x, such that x is a male student and f be equals to y, such that y is a female student, then M intersection F is empty. Female student, can you find a student that is both male and female? The answer is no. So this is empty. And so we say M and F are disjoint subsets, because they don't have elements in common. Next, we discuss about a Venn diagram. Venn diagram. A Venn diagram is a pictorial representation of sets together with their relationships. So a Venn diagram is a picture, that represents sets together with their own relationships, such as intersection, union, and so on. So Venn is the name of a famous mathematician. Now, the universal set is represented by a rectangle. While its subsets are represented by circles within the rectangle. Example number 1, you can have a universal set. Just use some right universal set inside. So every element here, every element inside within the rectangle is an element of the universal set. While if I write A, I mean a subset of the universal set. I can write B like this, meaning A and B are subsets of the universal set. But if the circle overlaps, then A and B intersect. A and B are not disjoint, meaning A intersection B is not empty. But here, there is no overlapping between the circles here, so A and B are disjoint. So here, we are saying A intersection B is equals to empty, and this represents disjoint subsets. Disjoint subsets. 2, we can represent it like this. So this one is, I have A, I have B. So the shaded portion here indicates A intersection B, meaning A intersection B is not empty because they have at least some elements in common. And the third diagram, I can write A and B. This is A, this is B, but this is the universal set. So the shaded portion here represents A union B. That's the union of two sets, A and B. Now, fourthly, I can write, we have, this is A. It's a subset of the universal set. If I shade outside A, the shaded portion here signifies A complement, or sometimes we write A prime like this. So meaning every element in the universal set which is not in A. Come up here. Look at our example. The set of male and female students. These are disjoint subsets. So this represents the male and this represents the female, or the female and the male respectively. So this is a diagrammatic representation of sets. We shall continue from here. Thank you for watching our video.